So we're going to get started with this picture that you see on your screen. It is the same thing on the Zoom screen share, but please, oh, I think everybody's in the Nearpod. So no, one of those is me. There's one person not in the Nearpod. So please go ahead and join the Nearpod. I'm going to turn off public chat because I don't want anybody to ruin it for anybody. But what we're going to do is we're going to compare and contrast these two diagrams, okay? We have learned a lot about one of these diagrams in particular, but there is another one, the second one with like the brackets and the plus that we have talked about. So I would like you to please go ahead and compare and contrast these using as many vocabulary words as you can. Okay, some vocabulary words that might help you are going to be things like metal or non-metal, protons, neutrons, atomic number, octet rule, hint, hint, Bohr diagrams, electronegativity. Think back in your brain, all this vocab that we've learned, compare and contrast these two diagrams. If you need to see the diagram, you can click it on your Nearpod and it will be bigger, or I have it on the big screen on the Zoom call. All right, 10 more seconds, throw those answers in. It looks like we got everybody but one person in the Nearpod, which is good to see. All right, so I'm going to share some of your classmates' numbers. The one on the left shows the amount of valence electrons an element, while the second one shows a charge. Very good. The first diagram is the neutral position. Excellent. And the second one is a cation diagram. Beautiful. Cation is a very advanced vocab word. It's not even official Regents vocab word. I just threw it in as extra this year. The left is a Lewis dot diagram. It shows the element symbol and it shows the amount of electrons in the last shell. The right is the element and the type of ion it is. Beautiful. Good. So I have here, this one here. The right, share please, is taking away electrons to fulfill the octet rule. Beautiful. This is the key thing I was looking for, but I do see a bunch of other ones focusing on the electrons, which is good. Focusing on the charge on the second one. Here we have the compare. This one person remembered to compare. Same element, same atomic number of 3, both metals. Excellent. Okay. And so what we are looking at is these are actually both Lewis dot diagrams. I know the second one doesn't look like it because there aren't any dots, because what happened to the dots? A lot of you said the dot here represents the valence electrons. And so how do we know that this one used to have a dot next to it? What on the second diagram tells us there used to be a dot? You can either type in the chat. Go ahead.
There's a plus charge in the bottom.
And what does corner top right? And what does a plus charge? Go ahead.
It means they lost an electron.
Exactly. To get from this original Lewis dot diagram, Li with 1 dot, lithium's electron configuration is 2-1. To lose that 1 electron, which is what lithium wants to do to fulfill the octet rule, which a few of you remembered that vocab, it is going to lose it. It's going to say goodbye, and it will take on a positive charge. So now, where did that electron go? That is what we're going to be learning about in this unit, chemical bonding and moles. We got a lot of vocab, so before we learn anything new, I have a quick question for you. No, we already did that. Get out of here. Today, I'm going to show you that you guys already know a lot when it comes to the basics of chemical bonding. You just don't know the words to describe it, okay? And so we're going to start off with an example. If you look at your screen, we have 2 elements, sodium and fluorine. Sodium's atomic number 11, Na. Fluorine's atomic number 9, the letter F. And I am telling you that they react to form a bond. If you look at the top, it says they react to form an ionic compound called sodium fluoride, NaF. We'll learn all that stuff later. But right now, I just want you to focus on the electrons. So now, using the chat or by raising your hand, don't just unmute yourself, please raise your hand. Why do you think sodium and fluorine work so well together? I am telling you they work well together, but look at the electrons. Why do you think they work so well together? Give yourself about a minute to think about it. You can type your answer in the chat either directly to me or to everybody if you're brave, or you can raise your hand. Carmel, I'll call on you first in just a moment, okay?
Because they're in the same
group.
Octet rule, octet rule, octet rule.
Oh my Sasha, I'm muting you. I could kick you
Octet
out of
rule.
the meeting, my friends. You can type in the chat. Everybody can hear you by typing rules in the chat. You have the ability to chat to everybody. Thank you, Raymond. Thank you, Sanu. Thank you, Ricardo Now. Okay. All right. Good. Before I read the answers in the chat, Karma, you raised your hand. So go ahead. Why do you think these guys work so well together?
To fulfill the octet rule, what is it? Sodium loses. Sodium loses an electron, and then that electron is then given over to fluorine. Yeah, pretty
Okay.
much so that they both fulfill the octet rule.
Good. Anybody else want to speak your answer? If not, I'll read some from the chat. Look at how much you guys already know.
Well,
In the
it
chat, somebody was talking. I didn't know who was talking. Go ahead.
fulfills the octet rule, and they might be in the same group, or maybe
You
they
got
have the amount of valence electrons, deficit amount of valence electrons.
Okay, good. So they are going to help each other fulfill the octet rule. They are not in the same group. If you're not looking at a periodic table, you don't have to have that memorized, okay? But a quick way you know they're not in the same group is because sodium has 1 valence electron, meaning it's in group 1, and fluorine has 7, meaning it's in group 17, okay? Karma, don't hurt your eyeballs, okay? And so in the chat, we have some answers. We have octet rule. We have sodium has 1 valence electron while fluorine contains 7. Excellent. Together, they make 8 electrons. Sodium has 1 more electron that makes the octet in F. In fluorine, sodium has the 1 electron that fluorine needs. 1 plus 7 is 8. They all complete the octet rule. You guys are getting it. The number 8 is magic. These two elements work well together because they can fulfill the octet rule, and both have the same electron configuration as neon. What is special about neon, my friends?
It's a noble gas.
It's a noble gas. Those noble gases,
Element.
they will pop up in your ed puzzle today. Yes, you're doing an ed puzzle today. They are elements that already fulfill the octet rule. And as a reminder, when atoms are reacting, they want to have the same electron configuration as the noble gases. They are not turning into the noble gases, but they do have the same electron configurations, okay? Very good. So if we look at this picture, sodium has 1 valence electron. As you all said in the chat and Karma verbally, sodium wants to become happy by getting rid of that electron. And luckily, fluorine has a spot right for it. And so fluorine will go ahead and take that electron, and then everybody is happy in terms of the octet rule. That's fine, but now how do these atoms stay together in a compound? When sodium loses an electron, what will sodium's net charge become if sodium loses an electron? Type it in the chat, please. Go ahead. And I want to see them flying in, everybody. Very good. I am seeing Karma got +1 to everybody. A few more people typed positive, but you guys got it. Hugo, I'll answer your question in a second, okay? So they're all going to form a +1. What is fluorine going to do when it gains an electron? What will fluorine's charge be? It is negative. So we have sodium becoming a +1, fluorine becoming a -1. What do we know about positive and negative charges when they come near each other? What do? You can unmute yourself to make it sound exciting. They attract. They do not explode. They do attract, okay? And so I have 2 magnets here. Yes, my magnets are shaped like water molecules. That is not because I'm a nerd with science decorations in my apartment. There's science behind this. We'll learn it later. But I have a positive end and a negative end. When positives and negatives come together, they attract. And that is exactly what is happening. We have a positive ion when sodium loses an electron. We have a negative ion when fluorine takes that electron, and they are going to stick together because of that positive negative attraction. Okay, they go magnet mode. It's finally done. You got it. Okay, so this is the basics of chemical bonding. Okay, if you come on over to the Zoom screen share, I actually have a GIF of the Bohr diagrams of these elements showing what is going on. So you can come look at it here. We have sodium here, 281, giving an electron to fluorine, which is 27. Why is that thing taking up half of the screen? Thank you very much. And so when we look at this, we'll notice that they each end up coincidentally with the same electron configuration, same as neon. But when this happens, that positive and negative happens, and then they come together to make a compound. Okay. This is one of the main types of chemical bonding. There's 3 types. We are going to focus on all 3 throughout this unit. This is called an ionic bond, which we'll learn about today in your ed puzzle. But officially, what is happening is that in order to become stable, meaning in order to not want to react with the world around them, atoms are going to try to become happy. And what we mean when we say happy atoms, they are atoms that are going to try and fulfill the octet rule by working with other elements. In this case, we had one that wanted to lose electrons, we had one that wanted to gain, and so they work together and form a compound so that everybody is happy because of the octet rule. There are some that don't really work that well together, because what if you have 2 atoms that both want to gain? What if you have 2 atoms that both want to lose? Those are going to be different types of chemical bonds, which we'll start looking at closer tomorrow. Okay? So what you are going to be doing today for your asynchronous work is you are going to be working on an ed puzzle assignment, and it is going to be like a merging of events, a chemical bond, if you will, between Edpuzzle and BrainPop. And so Tim and Moby are going to walk you through some of the basics of the main types of chemical bonds. They're actually going to talk about water. And so you'll be able to see why water needs 2 hydrogens and 1 oxygen in order for everybody to be happy. Okay. So with asynchronous work, you are given this 25 minutes to work on this. Okay. 24, sorry, I'm ending 1 minute late. But the reason I'm ending 1 minute late is because a lot of you were late to class today, and so I didn't get started right away. But we have a lot of other things. Goodbye, Miss Iqbal. We have a lot of things going on in Unit 3, so please try to get here on time. If you need to set a reminder on your phone that's 1:50, so that way you're ready to go at 1:55, please do so. I also have on your Google Calendar the meeting link. You can set up a notification for you. But please get here on time, because we're going to start moving pretty fast in chemistry. We got a lot to get through and very weird situation to get through it in. Okay. So to read, a great day. I will see you tomorrow. Work on your ed puzzle, my friends. Goodbye.